Tonight on The Sleepy Scientist, we're drifting gently through the vast cosmic ocean of time itself, where the familiar flow of moments might softly reverse, carrying us backward through the quiet tapestry of existence. In the gentle darkness of space, we'll explore what would happen if time itself began to flow in the opposite direction, like a cosmic river changing its course through the eternal night. In the quiet space of our imagination, we can envision a universe where cause and effect exchange their gentle roles, where the arrow of time turns around like a sleeping bird changing direction on the wind. This is not a frightening thought, but rather a peaceful contemplation of one of the most profound mysteries that scientists have ever pondered in the soft glow of observatory lights and the whispered equations of theoretical physics. As we begin our journey tonight, let us settle into the comfortable embrace of wonder, knowing that we are about to explore concepts that stretch the mind gently, like warm honey spreading across the surface of consciousness. The reversal of time is not merely a science fiction fantasy, but a legitimate area of scientific inquiry that touches the very foundations of physics, cosmology, and our understanding of reality itself. Gently, we discover that time is perhaps the most mysterious dimension of our universe, flowing always forward in our daily experience, yet governed by physical laws that, in many cases, work equally well in both directions. It is as if the universe keeps a quiet secret about the nature of temporal flow, one that we are only beginning to understand through the patient work of physicists and cosmologists who spend their nights gazing into the depths of space and time. The concept of time reversal begins with a simple observation that has puzzled scientists for generations. Most of the fundamental laws of physics are what we call time-symmetric. This means that if you were to film a fundamental particle interaction and play it backward, the reversed version would still obey the same physical laws. It's like watching a gentle dance performed in reverse. The steps remain valid, even as they flow in the opposite direction. In the soft embrace of quantum mechanics, particles dance their eternal ballet according to equations that barely distinguish between forward and backward in time. The Schrödinger equation, that fundamental description of quantum reality, treats time as a parameter that can flow in either direction, like a peaceful stream that might choose to reverse its course without violating any of the deep laws that govern its flow. Yet in our everyday experience, time seems to have a definite direction. We remember the past but not the future. We see coffee cups break when dropped but never see the fragments spontaneously reassemble. We watch our breath condense in cold air but never see the condensation spontaneously gather itself back into our lungs. This apparent contradiction between the time-symmetric laws of physics and our one-way experience of time is one of the gentlest puzzles in all of science. As our journey continues into the quiet realm of thermodynamics, we encounter the concept of entropy, the measure of disorder in a system. In our familiar universe, entropy tends to increase with time, like flowers slowly wilting, or like the gentle spreading of perfume through a room. This increase in entropy gives time its arrow, its preferred direction of flow. But what would happen if this arrow turned around? What if entropy began to decrease instead of increase? The implications ripple outward through every aspect of physics and cosmology like gentle waves across a still pond. In a time-reversed universe, the fragments of that coffee cup would spontaneously leap from the floor and reassemble themselves into wholeness. The scattered perfume would gather itself back into its bottle. The gentle chaos of our world would organize itself into increasingly perfect order. Let's drift into the contemplation of what this might mean for the largest structures in our universe. Imagine, if you will, galaxies slowly rotating backward through space, their spiral arms unwinding like cosmic flowers closing their petals for the night. The stars within these galaxies would begin a strange reversed journey through their life cycles, growing younger instead of older, burning brighter instead of dimmer. In this backward universe, a dying red giant star would begin to shrink and heat up, pulling material back from the space around it instead of casting it off in stellar winds. The star would grow smaller and hotter, reversing through the stages of its evolution until it became a young, energetic main sequence star once again. Eventually, it would continue its backward journey, condensing from a diffuse cloud of gas and dust until it disappeared entirely into the cosmic medium from which it was born. The peaceful death throes of massive stars would reverse into gentle birth cries. Supernovae would unexplode, pulling their scattered material back together and condensing into massive stars that would then proceed to live their lives in reverse. Black holes, those mysterious gravitational wells from which nothing can escape in our forward-time universe, would begin to emit material, instead of consuming it, slowly shrinking, until they disappeared entirely, leaving behind the massive stars from which they originally formed. Now we float toward an even more profound consideration. What would happen to the fundamental particles that make up all matter in our universe? In a time-reversed cosmos, the natural radioactive decay that slowly transforms unstable atomic nuclei would reverse. Instead of uranium atoms spontaneously breaking apart into smaller elements, these smaller elements would spontaneously combine to form uranium. The gentle radioactive glow that emanates from certain materials would become a gentle radioactive absorption as energy flows backward into atomic nuclei instead of outward from them. The cosmic microwave background radiation, that faint afterglow of the Big Bang that permeates all of space, would begin to strengthen instead of weaken. This gentle whisper of ancient light would grow louder and brighter as the universe contracted, instead of expanded. The photons that have been traveling through space for nearly 14 billion years would begin their return journey, carrying information backward through time toward the cosmic event that created them. In the quiet space of quantum field theory, virtual particles would dance their strange ballet in reverse. These fleeting entities that constantly pop into existence and disappear in the quantum vacuum would reverse their eternal choreography. Instead of particle-antiparticle pairs appearing and then annihilating, they would first separate from pure energy and then come together to create that energy. In a gentle quantum reversal, gently, we discover that even the expansion of space itself would reverse in our backward universe. The cosmic expansion that has been stretching the fabric of space-time for billions of years would become a cosmic contraction. Distant galaxies would begin to move toward each other instead of away, their light shifting from red toward blue as they approached rather than receded. This cosmic contraction would be so gradual at first that it would be barely perceptible, like the gentle settling of a house that has stood for centuries. But as time continued to flow backward, the contraction would accelerate, drawing all matter and energy in the universe closer together. The vast spaces between galaxy clusters would shrink, the galaxy clusters would merge, and eventually even individual galaxies would begin to collide and coalesce. As our backward journey through time continues, we would witness the gentle undoing of cosmic evolution. The heavy elements forged in the hearts of stars would begin to break apart, transforming back into the hydrogen and helium from which they were created. The carbon in our bodies, the oxygen we breathe, the iron in our blood, all would slowly decompose back into the primordial elements of the early universe. The very atoms that make up planets and asteroids and comets would begin to dissociate. Rocky worlds would dissolve into clouds of individual atoms, which would then begin the process of separating into their constituent protons, neutrons, and electrons. The gentle gravitational forces that hold solar systems together would be overwhelmed by the cosmic contraction, and planetary orbits would decay as everything in the universe drew closer together. Let's drift into the contemplation of what this means for the phenomenon of life itself. In our time-reversed universe, the complex processes of biology would flow in the opposite direction. Instead of organisms growing and evolving and becoming more complex over time, life would become simpler and more primitive, eventually dissolving back into the non-living matter from which it emerged billions of years ago. The gentle process of aging would reverse. Elderly organisms would grow younger, their cells regenerating instead of deteriorating. Wounds would heal by opening up again. Scars would reappear before the injuries that caused them, and the accumulated damage of a lifetime would slowly undo itself. Eventually, these rejuvenating organisms would shrink back into embryos, then into single cells, and finally into the organic molecules that first sparked the miracle of life. On countless worlds throughout the cosmos, consciousness itself, that mysterious property of sufficiently complex arrangements of matter, would begin its own backward journey. Thoughts would flow in reverse. Memories would transform from past experiences into future expectations, and the entire structure of awareness would reorganize itself around a backward-flowing stream of experience. In the quiet space of neuroscience, we know that consciousness emerges from the complex interactions of billions of neurons in the brain. In our time-reversed universe, these interactions would slowly simplify. The intricate neural networks that give rise to thought and emotion, and memory would begin to disconnect and dissolve. The gentle electrochemical signals that carry information through the nervous system would reverse their flow, carrying information backward through neural pathways until the entire structure of consciousness collapsed back into unconsciousness. This is not a violent or frightening process, but rather a peaceful return to simplicity, like a complex musical composition slowly resolving into a single, pure note. The accumulated wisdom and experience of countless generations of conscious beings would flow backward through time, eventually returning to the primordial silence from which it first emerged. As our journey continues through this backward-flowing cosmos, we encounter phenomena that would seem magical in our forward time universe, but are simply natural consequences of reversed causality. Heat would flow from cold objects to warm ones, making ice cubes in a glass of water spontaneously freeze the water, while melting themselves back into liquid. The gentle random motion of gas molecules would organize itself into directed flows, creating pressure differences where none existed before. Friction, that force that always opposes motion in our familiar universe, would reverse its role. Instead of converting kinetic energy into heat, it would convert heat into kinetic energy, causing objects to spontaneously accelerate rather than slow down. A ball rolling across the ground would begin to speed up as thermal energy from the environment flowed into its motion. Eventually, it would roll backward up the hill from which it had originally descended, returning to its starting point with exactly the energy it had possessed at the beginning. The electromagnetic forces that govern so much of the physical world would also reverse their familiar behavior. Instead of like charges repelling and opposite charges attracting, the flow of cause and effect would reverse, though the underlying mathematical relationships would remain the same. Electric currents would flow in response to magnetic fields in ways that seem backwards to us, and magnetic fields would organize themselves around future electric currents rather than past ones. Light itself would behave in fascinating ways in our time-reversed universe. Photons would emerge from the surfaces that normally absorb them and travel backward through space. Toward their sources, a mirror would emit light that would travel through space and eventually converge on light bulbs, and stars which would absorb this light instead of emitting it. The gentle glow of stars would become a gentle absorption of light from throughout the cosmos. Now we float toward the consideration of gravity, that fundamental force that shapes the large-scale structure of our universe. In a time-reversed cosmos, gravity would still attract masses toward each other, but the overall dynamics of gravitational systems would flow in reverse. Planets would spiral outward from their stars instead of inward, returning to the distant regions of space from which they originally formed. Moons would slowly escape from their planetary orbits, drifting back into independent existence as asteroids and comets. The gentle tidal forces that currently cause Earth's rotation to slow down would reverse, causing our planet to spin faster instead of slower. The Moon, which currently moves away from Earth at a rate of about 1.5 inches per year, would begin moving closer, its orbit tightening as it traveled backward through the gravitational interactions that have been shaping the Earth-Moon system for billions of years. Binary star systems, where two stars orbit around their common center of mass, would undergo a fascinating transformation. Currently, such systems lose energy through gravitational waves, ripples in space-time itself, causing the two stars to spiral slowly inward toward each other. In our time-reversed universe, these gravitational waves would flow backward through space-time, adding energy to the binary system and causing the two stars to spiral outward, eventually separating completely and go in their separate ways through the cosmos. Gently, we discover that even the process of planetary formation would reverse in our backward-flowing universe. The accretion of dust and gas that currently builds planets would become a process of dispersal, and dissolution. Rocky planets would slowly break apart, their material spreading back into the protoplanetary disks from which they formed. These disks would then expand and thin until they merged with the general interstellar medium, erasing all trace of the planetary systems that once existed. Gas giant planets would undergo their own reverse evolution. Instead of continuing to accrete gas from their surroundings, they would begin to shed their atmospheric envelopes back into space. Jupiter and Saturn and their distant cousins would slowly shrink, losing their majestic atmospheres and eventually revealing the small rocky cores that lie hidden beneath their gaseous exteriors. Even these cores would eventually dissolve, returning to the cosmic dust from which they originally condensed. The asteroid belts and comet clouds that populate planetary systems would also reverse their evolution. Instead of being gradually depleted by collisions and gravitational perturbations, they would grow richer and more populous as material flowed back into them from the planets and moons that originally formed from their substance. The gentle rain of meteors that currently brings cosmic material to planetary surfaces would reverse, lifting material from those surfaces and returning it to space. Let's drift into the contemplation of stellar evolution in our time-reversed universe. The nuclear fusion reactions that currently power stars would reverse, though this requires careful consideration of quantum mechanics and nuclear physics. In the extreme conditions at the hearts of stars, hydrogen nuclei overcome their natural electrical repulsion and fuse together to form helium, releasing tremendous amounts of energy in the process. In our backward universe, this fusion process would reverse. Helium nuclei would spontaneously break apart into hydrogen nuclei, absorbing energy instead of releasing it. Stars would become cosmic energy sinks rather than energy sources, drawing energy from their surroundings and storing it in the form of increasingly light atomic nuclei. The gentle thermonuclear fires that have burned in stellar cores for billions of years would become thermonuclear refrigerators, cooling their surroundings instead of warming them. This reversed stellar evolution would have profound consequences for the cosmos as a whole. Instead of enriching the interstellar medium with heavy elements created through nuclear fusion, stars would impoverish it, breaking down heavy elements back into primordial hydrogen and helium. The gentle stellar winds that currently carry enriched material throughout galaxies would reverse, drawing material back into stellar cores where it would be simplified rather than enriched. The spectacular deaths of massive stars in supernova explosions would also reverse in our backward universe. Instead of violently dispersing their material throughout space, these events would become cosmic vacuum cleaners, gathering material from vast regions of space and compressing it into newly formed massive stars. The shock waves that currently propagate outward from supernova explosions would converge inward, focusing cosmic material into points where new stars would spontaneously appear. Neutron stars, those incredibly dense remnants of massive stellar explosions, would begin to expand and cool in our time-reversed cosmos. The intense magnetic fields and rapid rotation that characterize young neutron stars would gradually diminish as these objects evolved backward through their life cycles. Eventually, they would expand back into normal massive stars, which would then continue their reverse evolution toward their birth in supernova implosions. As our journey continues through this backward-flowing universe, we encounter the fascinating reversal of wave phenomena throughout the cosmos. Sound waves would flow backward from their receivers to their sources, creating a universe where echoes precede the sounds that create them. The gentle ripples that spread outward when a stone is dropped into still water would instead converge inward, spontaneously lifting stones from the bottom of ponds and lakes. Electromagnetic waves would also reverse their propagation. Radio signals would flow backward from receiving antennas to transmitting antennas, carrying information in the opposite direction through time. The cosmic radio sources that astronomers study, pulsars, quasars, and radio galaxies, would become cosmic radio sinks, absorbing radio waves from throughout the universe instead of emitting them. Even the quantum mechanical waves that describe the probability of finding particles in various locations would reverse their evolution. The wave functions that currently evolve forward in time according to the Schrödinger equation would evolve backward, creating a universe where quantum effects flow in reverse. Quantum tunneling. where particles pass through barriers they shouldn't classically be able to cross, would become quantum untunneling, where particles spontaneously approach barriers and are reflected back the way they came. Now we float toward the consideration of thermodynamic processes in our time-reversed cosmos. The second law of thermodynamics, which states that entropy always increases in isolated systems, would effectively reverse. Instead of heat flowing from hot objects to cold objects, thermal energy would flow from cold objects to hot objects, creating temperature differences where none existed before. This reversal of thermodynamic flow would create a universe of spontaneous organization, rather than spontaneous disorder. Ice cubes would form in warm water while heating the surrounding liquid. Gases would spontaneously compress themselves, creating regions of high pressure and low temperature. The gentle mixing that normally homogenizes systems would reverse, causing mixed systems to spontaneously separate into their component parts. The concept of thermal equilibrium would take on new meaning in our backward universe. Instead of being the final state toward which all thermodynamic systems evolve, thermal equilibrium would become the initial state from which all systems diverge. Temperature differences would spontaneously appear in uniform systems, creating the potential for work to be extracted from thermal gradients that form spontaneously, rather than being imposed from outside. Chemical reactions would also reverse their familiar behavior in our time-reversed cosmos. Instead of proceeding from reactants to products while increasing the overall entropy of the universe, chemical reactions would proceed from products to reactants while decreasing entropy. Combustion would become a process where ashes and gases spontaneously organize themselves into fuel, absorbing heat and light instead of releasing them. The gentle process of dissolving would reverse, causing dissolved substances to spontaneously precipitate out of solution. Salt would crystallize out of seawater, sugar would separate from coffee, and the countless dissolved minerals that make rivers and oceans chemically complex would return to solid form, simplifying the chemical composition of natural waters. Gently, we discover that even the process of phase transitions would reverse in our backward flowing universe. Instead of ice melting when heated, it would freeze when cooled by absorbing heat from its surroundings. Water vapor would condense not because it cooled, but because it warmed up by transferring thermal energy to the surrounding air. The familiar relationship between temperature and phase would invert, creating a world where heating causes freezing and cooling causes boiling. Let's drift into the contemplation of biological processes in our time-reversed cosmos. The intricate machinery of life, from the molecular level to the ecosystem level, would begin its gentle journey backward through evolutionary time. The process of natural selection would reverse, causing populations to become less adapted to their environments rather than more adapted. Genetic mutations, which normally introduce random changes into the genetic code of organisms, would reverse their effects. Instead of creating new genetic variations, mutations would eliminate existing variations, causing the genetic diversity of populations to decrease over time. Eventually, all members of a species would converge toward identical genetic sequences, representing the ancestral form from which the species originally evolved. The development of individual organisms would also reverse in fascinating ways. Instead of growing from embryos into adults, organisms would shrink from adults into embryos. The complex process of embryonic development, where a single fertilized cell divides and differentiates into the countless specialized cell types that make up a multicellular organism, would reverse. Specialized cells would de-differentiate and merge back into the single cell from which they originated. Reproduction itself would take on new meaning in our time-reversed universe. Instead of parents producing offspring, offspring would somehow produce parents, though the exact mechanism for this reversal strains our understanding of causality and identity. Perhaps it is better to think of reproduction reversing in the sense that the genetic information flow reverses. Instead of genetic material flowing from parents to children, it would flow from children to parents, somehow carrying hereditary information backward through time. The process of learning and memory formation would also reverse in conscious organisms. Instead of accumulating memories and knowledge over time, these would gradually be lost. causing organisms to become less knowledgeable and experienced as they aged backward. The neural pathways that encode memories would slowly dissolve, returning brains to the blank slate condition of newborns, and eventually to the unconscious simplicity of early embryonic development. Ecosystems would undergo their own reverse evolution in our backward-flowing cosmos. Food webs would simplify rather than complexify, with predator-prey relationships reversing their normal dynamics. Instead of predators hunting and consuming prey, the material and energy would flow in the opposite direction, with prey somehow feeding predators who would then release their victims unharmed. The carbon cycle, that fundamental process that moves carbon atoms through living and non-living systems on Earth, would reverse its flow. Instead of plants absorbing carbon dioxide from the atmosphere and converting it into organic compounds through photosynthesis, they would break down organic compounds and release carbon dioxide. The oxygen that plants currently produce as a byproduct of photosynthesis would instead be consumed, gradually depleting the atmosphere of this vital gas. As our journey continues through this time-reversed biosphere, we witness the gentle undoing of millions of years of evolutionary progress. Complex organisms would slowly simplify, losing sophisticated organs and behaviors that took eons to evolve. Mammals would lose their warm-bloodedness and complex brains, eventually transforming back into the simple reptilian forms from which they evolved. These reptiles would continue their backward journey, becoming amphibians, then fish, then simple marine creatures, and eventually single-celled organisms. The great extinction events that punctuate Earth's geological history would reverse in our backward cosmos. Instead of causing mass die-offs, these events would become mass resurrection events, where extinct species would spontaneously reappear from the geological record. The asteroid impact that killed the dinosaurs would become a cosmic gift, somehow restoring these magnificent creatures to life instead of destroying them. Now we float toward the consideration of geological processes in our time-reversed Earth. The slow movement of tectonic plates would reverse direction, causing continents that are currently drifting apart to move back together. The Atlantic Ocean would slowly close as North America and Europe approached each other, eventually reuniting the supercontinent Pangaea that broke apart hundreds of millions of years ago. Mountain ranges would begin to erode in reverse, growing taller instead of shorter as weathering processes somehow added material instead of removing it. The gentle flow of rivers would reverse, carrying sediments upstream from the oceans to the mountains, gradually building up the landscape instead of wearing it down. Canyons would fill in with rock and soil, returning to the level plains from which they were carved by ancient rivers. The rock cycle would also reverse its familiar flow. Instead of igneous rocks weathering into sediments that form sedimentary rocks, that transform into metamorphic rocks that melt back into igneous rocks. This cycle would flow backward. Sedimentary rocks would somehow transform directly into the weathered fragments from which they formed, while metamorphic rocks would cool and simplify back into their original sedimentary or igneous forms. Volcanic activity would take on new meaning in our time-reversed Earth. Instead of erupting molten rock from deep within the planet, volcanoes would somehow absorb surface material and transport it downward into the Earth's interior. The gradual cooling of our planet that has been occurring since its formation would reverse, causing the Earth's core to grow hotter instead of cooler as thermal energy flowed inward from space instead of outward from radioactive decay. The formation of fossil fuels would also reverse in our backward-flowing world. Oil and natural gas, which formed over millions of years from the compressed remains of ancient organisms, would begin to decompose back into their biological origins. Coal seams would transform back into the ancient swamps and forests from which they formed, somehow restoring these long-lost ecosystems to the Earth's surface. Gently, we discover that even the water cycle would reverse its familiar pattern. Instead of water evaporating from oceans and lakes, rising into the atmosphere, and falling as precipitation, this cycle would flow backward. Rain would fall upward from the ground into the sky. Streams and rivers would flow uphill toward their sources, and the vast circulation patterns that drive weather and climate would reverse their direction. The formation of clouds would become a process of cloud dissolution. as water vapor somehow organized itself into liquid droplets that then dispersed back into individual molecules. The beautiful spiral patterns of hurricanes and cyclones would unwind, releasing their stored energy back into the thermal gradients that originally created them. Let's drift into the contemplation of atmospheric processes in our time-reversed world. The gentle mixing that currently homogenizes our atmosphere would reverse, causing the uniform mixture of gases to spontaneously separate into distinct layers. Oxygen might concentrate at one altitude while nitrogen gathered at another, creating an atmosphere stratified by molecular weight rather than mixed by turbulent winds. The ozone layer, which currently protects life on Earth from harmful ultraviolet radiation, would begin to dissipate as ozone molecules spontaneously decomposed back into ordinary oxygen. This would not be catastrophic in our time-reversed world, however, because the Sun would also be evolving backward, gradually becoming less energetic and emitting less harmful radiation. The greenhouse effect that currently warms Earth's surface would reverse, causing greenhouse gases to cool the planet instead of warming it. Carbon dioxide, methane, and water vapor would somehow absorb thermal energy from the Earth's surface and radiate it into space more efficiently than they currently absorb energy from the Sun, and radiate it downward, where the patterns would reverse their familiar behavior in fascinating ways. High-pressure systems would become low-pressure systems and vice versa, as the thermal and pressure gradients that drive weather flowed backward through the atmosphere. Storms would begin at their point of dissipation and strengthen as they moved backward along their paths, eventually reaching maximum intensity at what we currently consider their point of origin. The jet streams that circle our planet and drive much of our weather would reverse direction, flowing from east to west instead of west to east. This would completely reorganize global weather patterns, causing deserts to bloom and rainforests to dry up as precipitation patterns shifted, to accommodate the reversed atmospheric circulation. As our journey continues through this time-reversed Earth, we witness the gentle reversal of the hydrological processes that have shaped our planet. For billions of years, the erosion that currently carves valleys and canyons would become a process of geological construction, building up landscapes instead of wearing them down. Sediments would flow upstream from river deltas to mountain peaks, reconstructing the highlands from the material that erosion has carried to the sea. The formation of soil would reverse, causing the rich organic layer that supports terrestrial life to decompose back into bare rock and organic matter. Earthworms and other soil organisms would work backward, removing organic material from the soil instead of adding it, gradually impoverishing the medium that supports plant growth. Glacial processes would also reverse in our backward-flowing world. Instead of glaciers slowly advancing and retreating in response to climate changes, they would somehow respond to future climate conditions, growing in anticipation of ice ages that haven't happened yet, and melting in preparation for warm periods that lie in the past. The carving action of glaciers, which currently creates dramatic landscapes like fjords and alpine valleys, would reverse into a filling action that would smooth out these dramatic features and restore the landscape to its pre-glacial condition. Moraines and other glacial deposits would somehow return to the ice that originally carried them, leaving behind smooth, uncarved terrain. Now we float toward the cosmic scale once again, considering how our time-reversed Earth would interact with the larger solar system. The gentle tidal forces that currently cause Earth's rotation to slow down, and the Moon to spiral slowly away from us would reverse their effects. Earth would spin faster and faster while the Moon approached closer and closer, recreating the rapid rotation and close lunar companion of our planet's youth. The bombardment of Earth by asteroids and comets would reverse, causing these impactors to somehow lift off from our planet's surface and return to space. The scars of ancient impacts would heal as crater-forming events reversed themselves, and the water that comets brought to early Earth would return to these icy visitors as they departed our planet. The formation of Earth's magnetic field would also undergo reversal in our backward-flowing cosmos. Instead of being generated by convective motions in the planet's liquid iron core, the magnetic field would somehow drive these motions, organizing the flow of molten metal deep within the Earth. The periodic reversals of Earth's magnetic field that occur naturally would perhaps become more frequent as the entire geomagnetic system evolved backward. Through its history, gently, we discover that even the formation of the Moon would reverse in our time-reversed solar system. The giant impact theory suggests that our natural satellite formed when a Mars-sized object collided with the early Earth, ejecting material that eventually coalesced into the Moon. In our backward universe, this process would reverse, with the Moon gradually spiraling inward toward Earth until it collided with our planet, somehow recreating the Mars-sized impactor that would then separate from Earth and go its own way. The formation of the solar system itself would begin its reversal. As our backward journey through time continued, the planets would slowly migrate away from their current orbits, eventually dispersing back into the protoplanetary disk from which they formed. This disk would expand and cool, gradually merging with the interstellar medium from which it originally condensed. The Sun would begin its own backward evolution, slowly expanding and cooling as nuclear fusion reversed in its core. Instead of converting hydrogen into helium and heavier elements, stellar nuclear synthesis would break down heavy elements back into primordial hydrogen. The solar wind that currently streams outward from the Sun would reverse direction, drawing material inward and adding mass to our star instead of depleting it. Let us drift into the contemplation of how other planetary systems throughout the galaxy would evolve in our time-reversed universe. The thousands of exoplanets that astronomers have discovered orbiting distant stars would begin their own backward journeys through planetary evolution. Gas giants would shed their atmospheres, terrestrial planets would dissolve back into cosmic dust, and the intricate orbital relationships that characterize planetary systems would slowly unwind. The process of planetary migration, where gravitational interactions cause planets to change their orbital distances over time, would reverse its effects. Hot Jupiters, gas giant planets that currently orbit very close to their stars, would migrate outward to the distant regions where they originally formed. The orbital resonances that create stable configurations in many planetary systems would gradually break down as planets returned to the random distribution of orbits they possessed. During their formation, rocky planets like Earth would undergo their own reverse evolution, shedding their atmospheres back into space and losing the differentiation that creates distinct layers of core, mantle, and crust. The heavy elements that currently make up terrestrial planets would somehow separate and disperse, leaving behind only the light elements that dominated the early solar nebula. The moons of the giant planets would also reverse their evolution, gradually spiraling away from their parent worlds, and eventually dispersing back into the cosmic medium. The complex moon systems of Jupiter and Saturn would simplify and disappear, taking with them the fascinating dynamics of tidal heating and orbital resonances that characterize these miniature planetary systems. As our journey continues through the time-reversed cosmos, we encounter the reversal of stellar formation processes throughout the galaxy. Instead of molecular clouds collapsing under their own gravity to form new stars, these clouds would expand and disperse as stars evolved backward and eventually dissolved into the interstellar medium. The shock waves from supernova explosions that currently trigger star formation by compressing nearby gas clouds would instead inhibit star formation, somehow preventing the collapse of molecular clouds and keeping the interstellar medium in a dispersed, low-density state. The stellar nurseries where new stars are currently being born would become stellar graveyards, where old stars go to dissolve. The spiral structure of galaxies like our own Milky Way would slowly unwind as the density waves that maintained these patterns flowed backward through galactic rotation. The beautiful spiral arms that concentrate stars and gas would fade away, leaving behind smooth, featureless disks of uniformly distributed material. Star clusters would disperse as gravitational interactions that currently hold them together somehow worked in reverse to scatter their member stars throughout the galaxy. The globular clusters that orbit the Milky Way like ancient satellites would gradually dissolve, adding their stars to the general galactic population and erasing the record of our galaxy's early star formation history. Now we float toward the consideration of galactic evolution on the largest scales. Galaxy mergers, which currently create larger and more massive galaxies through gravitational interactions, would reverse, causing large galaxies to split apart into smaller components. The The supermassive black holes that lurk at the centers of most galaxies would slowly evaporate through Hawking radiation, removing the gravitational anchors that help hold galactic structures together. The cosmic web of dark matter that provides the scaffolding for galactic formation would begin to dissolve as structure formation reversed on cosmological scales. Instead of matter clumping together under the influence of gravity to form increasingly complex structures, these structures would smooth out and disperse, returning the universe to the nearly uniform state it possessed shortly after the Big Bang. Dark energy, that mysterious force that currently accelerates the expansion of the universe, would reverse its effects in our time-reversed cosmos. Instead of causing space to expand faster and faster, dark energy would cause space to contract faster and faster, drawing all matter and energy in the universe closer together in an accelerating cosmic collapse. Gently, we discover that even the cosmic microwave background radiation would evolve backward in our time-reversed universe. Instead of growing cooler and more redshifted as the universe expands, this ancient afterglow of the Big Bang would grow warmer and bluer as the universe contracted. The tiny fluctuations in this radiation that currently provide the seeds for all cosmic structure would gradually smooth out, erasing the blueprint for galaxies and galaxy clusters. The process of Big Bang nucleosynthesis, which created the light elements shortly after the universe began, would reverse as our backward journey approached the cosmic beginning. Instead of protons and neutrons combining to form deuterium, helium, and lithium, these light elements would break apart back into their constituent nucleons, gradually simplifying the nuclear composition of the universe. Let us drift into the contemplation of what would happen to fundamental forces and particles as our time-reversed universe approached its moment of origin. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, might begin to unify as the universe contracted and heated up, reversing the process of symmetry breaking that occurred during the first moments after the Big Bang. Particles and antiparticles would dance their eternal ballet in reverse, with the slight asymmetry that currently favors matter over antimatter gradually diminishing. The cosmic abundance of matter would slowly decrease as particles and antiparticles found each other and annihilated, converting their mass back into pure energy that would contribute to the increasingly intense radiation that filled the contracting universe. The Higgs field that gives mass to fundamental particles would gradually weaken as the universe heated up, causing particles to become lighter and more symmetric. Eventually, the Higgs field would disappear entirely and all particles would become massless, moving at the speed of light through a universe that was rapidly approaching the moment of its own beginning. Quantum fluctuations in the vacuum itself would reverse their effects, somehow smoothing out the uncertainties in virtual particles that currently create a constantly changing quantum foam at the smallest scales. The zero-point energy of the vacuum would decrease instead of remaining constant, contributing to the overall cosmic contraction. As our backward journey through time nears the cosmic beginning, space and time themselves would begin to lose their familiar properties. The smooth fabric of space-time described by Einstein's general relativity would become increasingly curved and eventually break down entirely as quantum effects dominated over classical physics at the Planck scale. The concept of causality itself would become increasingly meaningless as we approached the moment when time began. In the quantum realm near the Big Bang, the distinction between cause and effect blurs, and our normal understanding of temporal sequence breaks down. Events would become quantum superpositions of all possible causal relationships, existing in a state of perfect temporal symmetry. Now we float toward the ultimate consideration. What lies beyond the Big Bang? In our time-reversed universe, as all matter, energy, space, and time converged toward the cosmic singularity, the very concepts that define physical reality would cease to have meaning. Temperature, density, and curvature would approach infinity, while volume approached zero in the mathematical description of this ultimate state. Perhaps in this moment before time began, our time-reversed universe would somehow connect with its time-forward counterpart, creating a cosmic cycle where the end becomes the beginning and the beginning becomes the end. Or perhaps the reversal of time would reveal new physics beyond our current understanding, opening doorways to higher dimensions or alternate realities. that exist outside the normal flow of temporal experience. In the quiet space of ultimate mystery, we might imagine that the reversal of time could reveal the deeper principles that govern the existence of universes themselves. Perhaps time is not fundamental but emergent, arising from more basic phenomena that exist in a realm beyond temporal flow. The reversal of time might strip away this emergent property, revealing the timeless foundation from which all temporal experience springs. Gently, we discover that contemplating time reversal brings us face to face with the deepest questions of existence itself. What is the nature of causality? Is the future as real as the past? Do the laws of physics contain within themselves the seeds of temporal direction, or is the arrow of time an emergent property of complex systems? The reversal of time challenges our most basic assumptions about the nature of reality. We assume that causes precede effects, that knowledge flows from past experience, and that consciousness moves through time from moment to moment. But if time could reverse, these assumptions would crumble, revealing new possibilities for understanding the relationship between mind and universe. In our time-reversed cosmos, memory would become prophecy, and prophecy would become memory. The past would become uncertain while the future became fixed, inverting our normal relationship with temporal knowledge. Free will would take on new meaning as conscious beings made choices that somehow determine past events rather than future ones. The very concept of identity would shift in fundamental ways. If time flowed backward, would you still be you as your body grew younger and your mind became simpler? Would consciousness itself reverse its flow, creating experiences that moved from complexity toward simplicity, from knowledge toward ignorance, from wisdom toward innocence? Perhaps the most profound implication of time reversal is what it reveals about the nature of existence itself. In a universe where time could flow in either direction, the present moment becomes not a fleeting instant between past and future, but a timeless point of perfect balance where all possibilities coexist in quantum superposition. As our journey through this time-reversed cosmos draws toward its close, we find ourselves returned to the fundamental mystery of time itself. Why does time flow in the direction it does? What gives rise to the arrow of time that defines our experience of causality, memory, and change? The expiration of time reversal reveals that this arrow is not built into the fundamental laws of physics, but emerges from the statistical behavior of complex systems. Entropy increases and time moves forward not because the universe must work this way, but because this is overwhelmingly the most probable way for it to behave. Time reversal shows us the vast realm of improbable but physically possible behaviors that exist alongside our familiar reality. In the gentle darkness of space and time, we have journeyed through a cosmos where every familiar process flows backward, where every natural law maintains its mathematical truth while expressing itself in reverse. We have seen stars grow younger instead of older, particles combine instead of decay, and consciousness itself reverse its flow from complexity toward simplicity. This backward universe is not a place of chaos or destruction, but rather a mirror that reflects the deep symmetries hidden within the laws of nature. It shows us that the forward flow of time that defines our experience is just one possible mode of cosmic evolution, selected from a vast space of possibilities by the statistical requirements of entropy and probability. The contemplation of time reversal brings us to a place of profound humility. Before the mysteries of existence, we realize that our forward-flowing universe, with all its complexity and beauty, represents just one thread in an infinite tapestry of possible realities. The laws of physics contain within themselves the potential for countless different modes of cosmic evolution, most of which remain forever hidden from our direct experience. Yet, in exploring these hidden possibilities through the gentle power of scientific imagination, we touch something deeper than mere intellectual curiosity. We connect with the fundamental wonder that drives all scientific inquiry, the recognition that reality is for stranger and more beautiful than our everyday experience suggests. The time-reversed universe we have explored tonight exists primarily in the realm of theoretical possibility, constrained by our current understanding of physics and cosmology. Real-time reversal on cosmic scales remains beyond our technological capabilities, and may always remain so. but the exploration of this possibility illuminates fundamental aspects of our actual universe that might otherwise remain invisible. By imagining how natural processes would behave if time flowed backward, we gain deeper insight into why they behave as they do in our forward-flowing reality. The statistical nature of entropy, the emergence of complexity, and the relationship between microscopic reversibility and macroscopic irreversibility all become clearer when viewed through the lens of temporal symmetry. As our contemplation of time reversal reaches its natural conclusion, we are left with a sense of the profound interconnectedness of all physical phenomena. Every process we have considered, from the quantum dance of particles to the cosmic evolution of galaxies, reveals itself as part of a unified tapestry governed by elegant mathematical principles that remain valid regardless of time's direction. The gentle flow of entropy that gives our universe its temporal direction emerges not from fundamental asymmetry in physical law, but from the statistical behavior of countless interacting systems. This insight connects the microscopic world of atoms and molecules to the macroscopic realm of stars and galaxies, showing how the arrow of time arises from the collective behavior of matter and energy throughout the cosmos. In the quiet space of scientific reflection, we recognize that exploring time reversal has brought us closer to understanding the deep nature of physical reality. The symmetries and asymmetries we have encountered reveal the beautiful mathematical structure that underlies all natural phenomena, from the smallest quantum fluctuations to the largest cosmological processes. The journey through our time-reversed cosmos has shown us that the familiar world of forward-flowing time represents just one possible expression of the underlying physical laws. These laws themselves are time-symmetric at the fundamental level, but they give rise to temporal asymmetry through the statistical mechanics of complex systems. This emergence of irreversibility from reversible components is one of the most profound insights in all of physics. Gently, we discover that contemplating time reversal has also revealed something important about the nature of consciousness and observation, our ability to imagine and explore counterfactual realities. Like the time-reversed universe demonstrates the remarkable power of conscious minds to transcend the limitations of direct experience and probe the deeper structures of reality through theoretical investigation. The scientific method itself depends on this ability to consider alternative possibilities and test them against observation and experiment. By exploring how nature would behave under different conditions, including the condition of reverse time, we develop a more complete understanding of the principles that govern actual natural phenomena. As we prepare to conclude our gentle journey through this backward-flowing cosmos, let us take a moment to appreciate the profound beauty of the universe we have explored. Even running in reverse, the cosmos reveals itself as a place of elegant order and mathematical harmony. Stars may grow younger instead of older, but they still follow the same physical laws that govern stellar evolution in our familiar reality. The reversal of time does not create chaos or meaninglessness, but rather reveals new dimensions of cosmic beauty. Galaxies unwinding their spiral arms, planets returning to their stellar nurseries, and consciousness itself flowing backward through evolutionary time. All of these reversed processes maintain their own internal logic and mathematical consistency. This consistency reflects the deep principle that the laws of nature are more fundamental than the specific temporal direction in which they happen to express themselves. In our observable universe, the mathematical equations that describe physical processes work equally well in both temporal directions, suggesting that time's arrow is an emergent rather than fundamental property of reality. The exploration of time reversal thus brings us to one of the most important insights in modern physics: the distinction between microscopic reversibility and macroscopic irreversibility. While individual particle interactions are time-symmetric, the collective behavior of many particles gives rise to irreversible phenomena, like the increase of entropy and the flow of heat from hot to cold objects. In our time-reversed universe, these collective phenomena would flow in the opposite direction while still obeying the same fundamental laws. This shows us that the arrow of time emerges from statistical mechanics, rather than being built into the basic structure of physical law. It is a property of complex systems rather than simple ones. of the macroscopic world rather than the microscopic realm. Now we float toward our final contemplation of what the journey through time-reversed cosmos has revealed about the nature of scientific understanding itself. Science progresses not just by observing what happens in nature, but by imagining what might happen under different conditions, and exploring the implications of these hypothetical scenarios. The time-reversed universe we have explored tonight could never be directly observed, yet thinking about it has illuminated fundamental aspects of the universe we actually inhabit. This demonstrates the power of theoretical exploration to reveal truths that remain hidden. When we limit ourselves to direct observation and experiment, through the gentle exercise of scientific imagination, we have touched upon some of the deepest mysteries of existence, the nature of time, causality, consciousness, and physical law. We have seen how these concepts are related to each other in ways that become visible only when we consider extreme scenarios like the complete reversal of temporal flow. The insights we have gained remind us that reality is far more subtle and surprising than our everyday experience suggests. The familiar world of forward-flowing time represents just one thread in a vast tapestry of possible realities, all governed by the same underlying mathematical principles, but expressing themselves in radically different ways. In the quiet space where science meets philosophy, we recognize that exploring time reversal has brought us face to face with fundamental questions about the nature of existence itself. What makes our forward-flowing universe real, while its time-reversed counterpart remains hypothetical? Are both equally valid expressions of the same underlying reality? Or does the direction of time's arrow select one possibility as more fundamental than the others? These questions may ultimately lie beyond the reach of empirical science, belonging instead to the realm of metaphysics and philosophy. Yet they rise naturally from our scientific exploration of temporal symmetry, showing how the pursuit of scientific understanding inevitably leads us toward the deepest mysteries of existence. Gently, we discover that the contemplation of time reversal has revealed something profound about the relationship between mind and cosmos. Our ability to imagine and explore counterfactual realities demonstrates that consciousness possesses a kind of temporal transcendence, allowing us to step outside the normal flow of time and consider alternative possibilities. This transcendent quality of consciousness may itself be related to the fundamental nature of time. Perhaps awareness exists in a realm that lies somehow outside the temporal flow, allowing conscious beings to observe and understand the passage of time without being completely subject to its constraints. The exploration of time reversal hints at this possibility by showing how the mind can conceive of temporal relationships that it has never directly experienced. As our journey through the time-reversed cosmos approaches its end, we find ourselves enriched with new perspectives on familiar phenomena. Every process we observe in our forward-flowing universe, from the formation of snowflakes to the evolution of galaxies, now reveals itself as just one member of a pair of time-symmetric possibilities. This doubling of our conceptual universe does not diminish the reality or importance of the processes we actually observe, but rather places them in a broader context that reveals their deeper significance. The forward flow of time that characterizes our universe is not an accident or arbitrary choice, but rather emerges from the statistical requirements of entropy and probability operating on cosmic scales. The time-reversed universe we have explored serves as a perfect mirror for our own cosmos, reflecting back to us the hidden symmetries and subtle relationships that might otherwise remain invisible. By seeing how natural processes would behave if time flowed backward, we gain insight into why they behave as they do in our forward-flowing reality. This mirroring effect reveals the profound unity underlying apparently diverse phenomena. The same principles that govern the evolution of stars also govern the development of consciousness, the formation of galaxies, and the flow of rivers. All of these processes share a common relationship to the arrow of time and the increase of entropy that drives temporal evolution. In the gentle darkness of theoretical space, we have witnessed the cosmic dance of matter and energy performing its eternal choreography in reverse. We have seen how this reverse dance maintains the same mathematical elegance and physical consistency as its forward-flowing counterpart, revealing the deep symmetries that underlie all natural phenomena. The beauty we have discovered In this time-reversed cosmos reminds us that the universe we actually inhabit is itself a place of profound beauty and mathematical harmony. The familiar processes of stellar evolution, planetary formation, biological development, and conscious experience all participate in the same cosmic dance, expressing the same underlying principles through their forward flow through time. As we prepare to return from our theoretical journey to the familiar reality of forward-flowing time, let us carry with us the insights we have gained. The contemplation of time reversal has revealed that our universe is both more strange and more beautiful than everyday experience suggests. It has shown us that the arrow of time emerges from deep statistical principles, rather than arbitrary cosmic accident. Most importantly, our exploration has revealed the remarkable power of human consciousness to transcend the limitations of direct experience and probe the fundamental nature of reality. Through theoretical investigation, this capacity for transcendent understanding may itself be one of the most remarkable phenomena. In a universe full of remarkable phenomena, the time-reversed cosmos we have explored exists primarily as a theoretical construction, a mirror held up to our actual universe to reveal its hidden properties and relationships. Yet, in exploring this hypothetical reality, we have gained real insight into the nature of time, causality, entropy, and the statistical foundations of physical law. These insights remind us that science is not just about cataloging observed phenomena, but about understanding the deep principles that govern all possible phenomena. By exploring what could happen as well as what does happen, we develop a more complete and profound understanding of the universe we inhabit. Now, as our gentle journey through time's reversal draws to its peaceful close, we find ourselves back in the familiar embrace of forward-flowing time, enriched by our theoretical exploration of its opposite. The universe around us continues its ancient dance of increasing entropy and evolving complexity, carrying us forward through the cosmic story that began nearly 14 billion years ago with the Big Bang. Yet we now understand this forward flow in a deeper way, seeing it not as the only possible mode of cosmic evolution, but as the most probable expression of underlying physical laws that are themselves time-symmetric. This understanding connects us more deeply to the cosmos while revealing the remarkable statistical foundations from which temporal direction emerges. The stars continue to burn hydrogen and helium in their cores, gradually enriching the cosmos with heavier elements. Galaxies continue their slow rotation and gradual evolution, forming new stars and planetary systems. Life continues its patient exploration of complexity and consciousness. All of these familiar processes now reveal themselves as expressions of deep principles that would work equally well in reverse, but which manifest in forward time because of the statistical requirements of entropy and probability. In the quiet space of cosmic contemplation, we recognize that our exploration of time reversal has brought us closer to understanding our place in the universal story. We are conscious participants in a cosmos that is constantly becoming more complex and differentiated, moving from simplicity toward ever greater richness of structure and experience. This forward evolution is not guaranteed by fundamental law, but emerges from the statistical behavior of countless interacting systems throughout space and time. We exist in a universe that has chosen, through the blind operation of probability and entropy, to explore the realm of increasing complexity rather than decreasing complexity, of emergent order rather than dissolving chaos. Our ability to understand and appreciate this cosmic choice through scientific investigation is itself a remarkable product of the universe's forward evolution toward greater complexity. The emergence of consciousness and scientific understanding represents one of the most profound developments in the cosmic story, allowing the universe to become aware of itself and its own evolutionary journey. Gently, we discover that contemplating time reversal has revealed something beautiful about the nature of scientific inquiry itself. Science represents a form of temporal transcendence, allowing conscious beings to step outside their immediate experience of time's flow and consider alternative possibilities. Through this transcendent capacity, we gain insight into the fundamental nature of the reality we inhabit. The theoretical exploration of time-reversed cosmos demonstrates how the scientific imagination can illuminate aspects of reality that remain hidden from direct observation. By considering how natural processes would behave under different conditions, we develop a deeper understanding of why they behave as they do under actual conditions. This power of counterfactual reasoning, the ability to consider what would happen if things were different, may be one of the most important capabilities that consciousness brings to the cosmos. It allows aware beings to understand their universe in ways that transcend the limitations of immediate experience, revealing the deep mathematical structures that govern all possible realities. As our contemplation reaches its natural conclusion, we are filled with wonder at the profound elegance of the universe revealed. Through our exploration of temporal reversal, the same mathematical laws that govern our forward-flowing cosmos would govern its time-reversed counterpart with equal validity, showing that the deepest principles of reality transcend the specific temporal direction in which they happen to be expressed. This transcendence of temporal direction reveals something profound about the nature of physical law itself. The equations that describe natural phenomena are more fundamental than the specific way those phenomena happen to unfold in time. They represent eternal mathematical truths that would remain valid, regardless of whether time flowed forward or backward, fast or slow. The beauty and consistency we have discovered in our time-reversed cosmos reflects the deeper beauty and consistency of these eternal mathematical principles. Whether stars evolve forward through their life cycles or backward through their death cycles, they obey the same elegant equations. Whether entropy increases or decreases, it follows the same statistical laws. Whether consciousness flows from simplicity toward complexity or from complexity toward simplicity, it emerges from the same physical processes. This mathematical constancy underlying temporal variability points towards something even more profound, the possibility that mathematics itself represents the deepest level of reality, with physical phenomena being expressions or manifestations of abstract mathematical relationships. From this perspective, both the forward-flowing universe we inhabit and the backward-flowing universe we have imagined are equally valid solutions to the same fundamental equations. In the gentle embrace of this mathematical universe, we find ourselves participants in something far grander than we might have imagined. From the perspective of everyday experience, we are conscious expressions of eternal mathematical principles, aware participants in the cosmic exploration of all possible relationships between matter, energy, space, and time. The journey through time-reversed cosmos has shown us that this exploration could proceed in many different directions, but that statistical principles have selected the particular direction. We observe the direction of increasing entropy, evolving complexity, and emergent consciousness. We exist in a universe that has chosen, through the operation of natural law, to become aware of itself. This self-awareness, reached through scientific understanding, represents one of the most remarkable achievements of cosmic evolution. Through beings like ourselves, the universe has developed the capacity to contemplate its own nature, to explore counterfactual possibilities like time reversal, and to discover the deep principles that govern all possible modes of existence. Now, as we float gently back toward the familiar shores of forward-flowing time, we carry with us the profound insights revealed through our theoretical journey. We understand more deeply why time flows as it does, why entropy increases rather than decreases, and why complexity emerges rather than dissolves in the cosmic processes around us. These insights do not diminish the mystery and wonder of existence, but rather deepen our appreciation for the subtle statistical principles that govern cosmic evolution. The arrow of time emerges not from arbitrary cosmic accident, but from the profound mathematical relationships that connect probability, information, energy, and consciousness in the ongoing story of universal becoming. The time-reversed universe we have explored remains forever hypothetical, existing only in the realm of theoretical possibility. Yet through contemplating this impossible cosmos, we have gained real insight into the possible cosmos we actually inhabit. This demonstrates the remarkable power of scientific imagination to illuminate aspects of reality that might otherwise remain hidden from view. As our gentle exploration draws toward its peaceful end, we find ourselves grateful for the opportunity to transcend, if only in imagination, the the normal constraints of temporal experience. The journey through reversed time has revealed the deep symmetries and subtle asymmetries that shape cosmic evolution, showing how complexity and consciousness emerge from the statistical behavior of simple components, following elegant laws. Most profoundly, our exploration has revealed something about the nature of consciousness itself, our ability to imagine and explore counterfactual realities. Like the time-reversed universe demonstrates, that awareness possesses a kind of temporal transcendence that allows it to step outside the normal flow of events and consider alternative possibilities. This transcendent quality of consciousness may represent one of the most significant developments in the entire cosmic story through conscious beings. The universe has developed the capacity to understand itself not just as it is, but as it could be under different conditions. This understanding reveals the deep principles that govern all possible realities, not just the particular reality we happen to inhabit. In the quiet space where our theoretical journey concludes, we recognize that exploring time reversal has brought us face to face with some of the deepest mysteries of existence, the nature of time, causality, consciousness, and physical law. While we may never fully solve these mysteries, the process of exploring them through scientific imagination brings us closer to understanding our place in the cosmic story. The universe revealed through our exploration is neither random nor predetermined, but rather represents the ongoing exploration of possibility space by mathematical principles. Operating through statistical processes, we are conscious participants in this exploration, aware expressions of the cosmos becoming aware of itself. Through the patient work of scientific understanding, as we prepare to conclude our journey through the time-reversed cosmos, let us take a moment to appreciate how far we have traveled together in imagination. We have witnessed stars growing younger, galaxies unwinding their spiral arms, and consciousness itself flowing backward through evolutionary time. We have seen entropy decrease instead of increase, creating spontaneous order where we normally expect gradual dissolution. Throughout this impossible journey, we have maintained our commitment to scientific accuracy and logical consistency. The time-reversed universe we explored obeys the same physical laws as our familiar cosmos, expressing them in unfamiliar ways that reveal hidden symmetries and unexpected possibilities. This consistency demonstrates the profound unity underlying apparently diverse phenomena. The mathematical elegance we discovered in our backward-flowing cosmos reflects the deeper elegance of the principles that govern both possible and actual realities. Whether time flows forward or backward, whether entropy increases or decreases, whether consciousness emerges or dissolves, all of these processes participate in the same cosmic dance of mathematical relationships expressing themselves through physical phenomena. This dance continues around us even now. As we return to the familiar experience of forward-flowing time, the stars burn their nuclear fuel and gradually evolve toward their eventual fates. Galaxies rotate and interact and slowly change their structure over cosmic ages. Life continues its patient exploration of complexity and awareness. Consciousness continues its remarkable journey of understanding and appreciation. All of these familiar processes now reveal themselves in a new light, illuminated by our theoretical exploration of their time-reversed counterparts. We understand more deeply why they proceed as they do, recognizing the statistical foundations from which temporal direction emerges, and the mathematical principles that govern all possible modes of cosmic evolution. Gently, we discover that our journey has returned us to the present moment with a deeper appreciation for the subtle miracle of existence itself. The forward flow of time that carries us through our daily experience emerges from deep principles of probability and statistics operating on scales. From the quantum to the cosmic, we exist in a universe that has chosen, through the blind operation of natural law, to explore increasing complexity rather than decreasing simplicity. Our capacity to understand and appreciate this choice through scientific investigation represents one of the most remarkable products of cosmic evolution. Through conscious beings, the universe has developed the ability to step outside itself and consider alternative possibilities, gaining insight into the fundamental principles that govern all possible realities. The time-reversed cosmos we have explored exists primarily as a theoretical mirror, reflecting back to us the hidden properties of the universe we actually inhabit. This mirror has revealed the statistical nature of time's arrow, the emergence of complexity from simple laws, and the remarkable transcendent capacity of consciousness to explore counterfactual possibilities. Through scientific imagination, as our contemplation of temporal reversal reaches its gentle conclusion, we find ourselves filled with wonder at the profound beauty and mathematical elegance revealed through our theoretical journey. The cosmos, whether flowing forward or backward through time, expresses the same deep principles of harmony and consistency that govern all natural phenomena. This consistency points towards something even more profound, the possibility that consciousness itself represents a fundamental aspect of cosmic reality, perhaps the means through which the universe becomes aware of its own mathematical nature. Our ability to explore impossible realities like the time-reversed cosmos through pure imagination demonstrates a kind of transcendence that may connect us to the deepest levels of existence. In the quiet space where theory meets reality, we recognize that our exploration of time reversal has brought us closer to understanding the profound mystery of our own existence. We are temporary arrangements of matter and energy that have somehow become aware of themselves and their cosmic context. This awareness allows us to transcend our immediate temporal experience and touch the eternal mathematical principles that govern all possible realities. The journey through reverse time has shown us that these principles would remain valid, regardless of the specific direction in which time happens to flow. This temporal independence reveals something profound about the nature of physical law itself. It transcends the particular circumstances under which it operates, expressing eternal mathematical truths through the changing phenomena of space and time. As we return to our familiar forward-flowing temporal experience, we carry with us the insights gained through our theoretical exploration. We understand more deeply why entropy increases, why complexity emerges, and why consciousness has appeared in our corner of the cosmos. These developments represent not inevitable outcomes, but statistical choices made by a universe exploring the space of all possible relationships between matter, energy, information, and awareness. Now as our gentle journey through the mysteries of temporal reversal draws toward its peaceful close, we find ourselves back where we began, floating in the vast cosmic ocean of space and time, contemplating the profound mysteries that surround our existence. Yet we are not unchanged by our theoretical voyage. We carry with us new understanding of the subtle statistical foundations from which the arrow of time emerges. The familiar processes of stellar evolution, planetary formation, biological development, and conscious experience now reveal themselves as expressions of deep mathematical principles that would work equally well in reverse, but which manifest in forward time because of the requirements of entropy and probability. Operating on cosmic scales, this understanding connects us more deeply to the mathematical foundations of reality, while revealing the remarkable statistical processes that have given rise to complexity and consciousness. In contemplating the possibility of time reversal, we have touched upon some of the deepest questions that conscious beings can ask about the nature of existence. What makes our forward-flowing universe real, while its time-reversed counterpart remains hypothetical? Are we discovering eternal mathematical truths or creating temporary conceptual constructions? Does consciousness transcend time or emerge from it? These questions may lie ultimately beyond the reach of empirical investigation, belonging to the borderland where science meets philosophy and metaphysics. Yet they rise naturally from our scientific exploration of temporal symmetry, demonstrating how the pursuit of understanding inevitably leads us toward the fundamental mysteries of existence itself. The time-reversed universe we have explored serves as a profound thought experiment that illuminates aspects of reality that might otherwise remain hidden. Through contemplating how natural processes would behave if causality flowed backward, we gain insight into why they behave as they do in our forward-flowing reality. This counterfactual reasoning represents one of the most powerful tools of scientific understanding. Our capacity for such reasoning may itself represent one of the most remarkable features of consciousness. Through beings like ourselves, the universe has developed the ability to step outside its own temporal flow and consider alternative possibilities. This transcendent capacity reveals mathematical principles and statistical relationships that govern not just the actual cosmos we inhabit, but all possible cosmos that could exist under different conditions. Good night from the sleepy scientist.